The way the Spitz system works is it actually is tied into the U.S. segment power system, and that system is I'll say isolated. The actual design of the electrical system has there's several ways you can achieve isolation. One of the best ways is to have a transformer in between. So the U.S. system's isolated, the electrical power system's isolated from the Russian segment via, in some cases, 2 transformers, in other cases just 1 transformer. When we go to Spitz, we're sending the ISS is sending over 120 volt power. The Spitz box itself is a transformer which steps it down to 28 volts. So we believe the power and so the Spitz the power on the shuttle side's isolated from the ISS side. The U.S. side electrically is isolated from the Russian side. So we believe that we're sufficiently isolated when we hook up Spitz. So our plan right now is to have no change, no additional isolation of the Russian computer system prior to the hooking up of that system. I will mention, if you recall, you may or may not have noticed during the flight, we actually isolated the new arrays. We're sending over power to the Russian segment, and it goes to that transformer I was describing. During the flight, we actually physically disconnected the power from those arrays to those transformers, and we hadn't hooked them back up. Today on orbit, our plan is to actually hook those up. In fact, it may have already occurred, to hook it up and to run power from the new arrays through those transformers into the Russian segment. And again, we've done sufficient analysis both on the U.S. side and the Russian side to feel comfortable in doing that. So we'll get that data point. And like I said, we don't expect that there'll be any significant change in the power system from hooking up the shuttle.
One follow-up on